Hi, my name's Elon, student ID 109246255. Today I'm going to be talking about the constraints of the project as well as the prototype testing and design during the engineering design and drawing propulsion project. First off, project constraints and limitations. So as per the criteria given by Cornelius, the car or the model itself cannot have any forward assistance, cannot fall over, cannot have any assistance to start moving, and cannot be touched or adjusted after starting or once being moved. Our initial design discussion consisted of three options. The first option we had was possibly 3D printing the car itself. This brought up a few challenges. First off, the design through the actual model and program itself, as well as the availability of 3D printing within the school, as we discussed that quite a few others sort of were thinking of doing the 3D printing. Second was the Lego and K'NEX, simply because a few of us did have some from a while back that we could use. And third option was balsa wood, which is both lightweight and would provide sturdiness to the car itself. So we did trial runs of the K'NEX as well as the balsa wood. We decided against the 3D printing just due to the time constraints and people having other commitments and things like that. So for the Lego and K'NEX trial runs, what we did notice is that when propulsion was applied to the vehicle, there was quite a lot of flexing throughout the chassis, which affected the accuracy of the travel of the car itself, as well as traction from using the plastic only wheels. So these were just plastic circles similar to bottle caps. We found that once propulsion was applied to the car, it had a hard time keeping line, which ended up all over the place. Now what we did is we added balsa wood to our prototype as well, which solved our sturdy chassis issue, but we still had the issue of traction and being able to grip the actual surface that it's travelling on. So our final discussion of the prototype, we discussed pros and cons of each. K'NEX being lightweight, easily available, and balsa wood increasing the sturdiness of the chassis. So the designers, or our group, decided on a K'NEX and balsa wood mix for our final prototype. Now, as you can see from the screen, our design was relatively cheap, $9.50. So recycled bottle, free from my recycling bin. Pump valve was $2 and the release valve was $1. Balsa wood was $4. We ended up cutting it in half, so most probably could have halved that cost initially. K'NEX wheels and axles, we estimated the price to be around $2.50, so all up it was $9.50 in total. So from the screen, our prototype 1 was using purely K'NEX, and what we did is we added rubber around the rear wheels and just left the front wheels bare plastic. This did help with traction, however with steering, because the front wheels didn't have any rubber on it, we found it was still a bit iffy direction wise. And so as we discussed, our final prototype was to add balsa wood. Now what happened during the K'NEX only run was that the bottle was producing too much thrust and so would clip out of the actual K'NEX restraints. So what we did is we used electrical tape connected to the balsa wood, sort of to enable maximum transfer of thrust to the chassis itself. So as you can see, so test run with the K'NEX, as I said before, the thrust was too much for the K'NEX to actually contain. And then our balsa wood and K'Nex, we used, so the balsa wood and K'Nex final prototype, we used one run without rubber around the wheels, and then the second run was with rubber, just to see if the added weight would affect our times or anything. So the first test was relatively successful because it was secured to the wood quite firmly. It did sort of produce the maximum speed that we were wanting. The only issue is that because there was no rubber around the tyres, again we ran into directional issues. So the second test did prove to be our most successful. Adding rubber obviously increased the traction of the vehicle and enabled it to go in a straight line, as well as producing maximum thrust due to the electrical tape used. Thank you for your time. That was my presentation. Cheers.